Hello.
Hello. Good
Yeah,
evening, sir.
good evening. Can you hear me?
Yes, sir.
Okay, last week we couldn't do classes. So what happened last couple of weeks? What have you done?
I did for organic, I did the chapter two and that reaction mechanism one.
Mm.
I'm halfway done with all the questions.
The action mechanism was being taught in your coaching, right?
Yeah, like from the book.
So
I'm
what
halfway.
you should be doing is look at the coaching module, whatever what reaction mechanisms they are teaching, and find them in the book. Find it in the textbook and read from there.
Yeah, I did that.
So are you understanding from the book what is going
Yeah,
on?
yeah,
Okay. Uh, so you're halfway through the reaction mechanisms that you need to understand, right?
yeah, like the questions part. Reading I did.
Questions, where are you doing from
That
the
book
book?
only. Yeah.
Okay. So which reaction mechanisms did they talk about so far?
They did SN1, SN2,
Hmm.
then they did SNI, SNNGP.
Mm-hmm.
Then they did SN AR, like the aromatic thing. I didn't read
Hmm.
SNI and SNAR.
Hmm.
Then I did. Then they did E1, E2, then E1 CP.
These ones you have read, right, from the book.
Yeah, SN1, SN2, E1, E2, and E1 CP. These ones are read because they're all in one place. I did that.
So you should feel like now you are getting it, what is going on, right? That should happen. The confidence should be there, कि you're understanding what is going on in these reaction mechanisms.
Yeah, that's there. Like I understand what's happening now, like properly. I'm still doing
Right.
some questions. But, hmm.
So the way to study organic is like that only. Like they will be teaching you very fast many things. In the book, you will see that they are in separate chapters, all of it, right?
Yeah.
So these will be in many different chapters. Slowly in the book, it will be introduced, but ultimately you have to understand it at that level, right?
Hmm. Yeah.
Did you have a test or something?
They canceled today's test because of the band.
Hmm.
So they
Okay.
rescheduled it for next week.
Okay. And what about the normal chemistry, chemical bonding, and all from the other textbooks?
That I did till chapter 8 all questions.
Uh, Chapters 8 you have studied.
Yeah, till there I did all questions.
Okay, so you're understanding what is going on.
Yeah, I had a few doubts.
So from the beginning, if you have any doubts in old chapters, also you can talk about that chapter 6 and all.
I'd written them somewhere, but I can't find them now.
Open the book and see the questions. You should be able to recognize it if there is some doubt somewhere.
Okay.
Chapter 6 exercises you tried out, right?
Yeah, I did for all.
So if you have understood the concepts, most of the exercises will be doable. It should not be very difficult.
No, there are only like one, two questions that
Hmm.
couldn't.
So far in this book, we have read about ionic bonds, and chapter 7 and chapter 8 are about covalent bonding, right?
Uh,
We have also done atomic structure, but right now we are doing chemical bonding, and covalent bonding is the topic of chapter 7, chapter 8, and also like the structures and all, how to understand the structures of molecules.
hmm.
So, so let's discuss like conceptually if there is any issue. Like chapter 7 was simple, right? Polar covalent, the electron dot structures, right?
Yeah, chapter 7 was fine.
Chapter 7 should be obvious. You just make electron dot structures trying to satisfy the octets, right?
Hmm. Yeah.
After that, there is one last section in chapter 7 which is about resonance. So sometimes there are multiple polar covalent structures that are possible for the same thing, right?
Yeah.
So if you look at, for example, ozone, he starts with ozone. So ozone formation can happen in two ways. You can draw a double bond on one side or on the other side, right?
Yeah.
So technically, the meaning of resonance is that when there are alternative structures, electron dot structures possible, it is not that one of them will be preferred or the other one will happen, right?
Yeah. It's a hybrid that thing.
The real structure is a mix of all of those structures, which means you will not say O double bond O like this or O double bond O like this. You will say that the actual structure is that these two electrons are actually delocalized over the whole molecule, right?
Yeah.
They are not here or not here, they are everywhere, right?
Hmm.
So resonance means basically delocalization of electrons. You should understand the meaning of the word. Localized electrons means they are in a particular location, right?
Yeah.
And delocalization means they are everywhere. So the bond order of both of the bonds actually is not 1 and 2 or 2 and 1. It is 1.5 and 1.5, roughly. Basically, when you see an actual ozone molecule, there is no difference between these two oxygen bonds and these two oxygen bonds, right?
Yeah.
Which means that it is neither going to be one or nor is it going to be two. It is going to be in the middle of bond, single bond and double bond, right?
Yeah.
So that is the example of resonance. There are many other examples. He has explained bond length, bond strength. Both of these things lie between single bond and double bond, right?
Lie between as in.
Bond or bond length and bond strength, both of it for ozone will be between what it should be for a single bond and what it will be for a double bond.
Yeah. Yeah.
So that is what is explained. There are several examples given in the book. You should see all of those examples and realize how to draw a resonance structure, right?
Hmm.
Every time there are multiple structures possible, the electrons will not be in one place. They will be all over the molecule wherever they are allowed to be. From the structures wherever they should be, all of there it will occupy everywhere, right?
Yeah.
So that is resonance basics. Now he has also given some examples of resonance in organic compounds. So same type of principle happens there also. Also, the electrons can move and they could be delocalized even in organic compounds and exist over multiple atoms, right?
Yeah.
Then there is a concept of formal charge. That is an important concept. Do you understand what formal charge is?
I did, but I didn't think it was important
It is
because
important.
our like my chemistry teacher told it's a very like, and I've never used it also
Your
in any
chemistry
time.
teacher doesn't know what he's talking about. Formal charge is actually quite important. The reason it is important is because formal charge helps us to predict which resonance structure is better.
But okay, okay.
Predict which reson. It's not always that it will be like ozone, where both the structures are identical. Do you understand what I'm saying? There
They
is
both
no
are.
difference between this molecule and this molecule. Therefore, it is completely symmetric finally when resonance happens.
Yeah, but in some they're more stable, so will exist. Like
So
that
it's
will be
not
more.
always going to be like this. There might be multiple resonance structures possible, and some of them are way better than some of them.
Hmm,
Do you
yeah,
understand what I'm saying?
yeah, yeah.
If some of them are much better than the others, then they will be dominating the actual structure that comes.
Uh, oh, okay. Hmm.
So formal charge is a super important concept because formal charges, if you know, then you will be able to predict which structure is better and which structure is less important. And that is going to be very important, especially in organic compounds when there is resonance.
Oh, okay.
It's not something that can be ignored, and just because you haven't used it doesn't mean it's not important. If it was not important, it would not have been given a separate section in this book. Do you
Okay.
understand what I'm saying?
Yeah.
The authors here are Cornell University profs, they know their thing.
Hmm. Okay.
These are not like some coaching class teachers, okay?
Okay.
The book is written by people who actually do research. And if they are putting it in a section and explaining with so much detail, that means it has some actual validity in real chemistry. So
Hmm.
you have to read this properly. So it is a simple concept. Formal charge you're saying is number of valence electrons in a free atom minus number of valence electrons in the bonded atom. So what that means is basically you calculate, let's do it for NO3 minus, right? Let's try to first draw the structure for NO3 minus nitrate ion, right? So valence electrons of nitrogen will be 5. For each oxygen, there are 6. So total 18 plus 5, 23 plus negative charge, so 24, right?
Yeah.
Now 24 electrons, 6 of them are occupied in single bond. So 18 are left. We would put 6, 6, 6 like this, right?
Ah, 3.
1 second, just hold on. There's someone at the door. 1 second.
Okay.
Right. So notice that right now the nitrogen is only having 6 electrons, right?
Yeah.
All the electrons have been used up, but all the oxygens are satisfied, but nitrogen is not satisfied. So we need to give a double bond here, right?
So nitrogen gets 8. Yeah.
So it will be like this, N single bond here and single bond here. And obviously this double bond could have come from any of the oxygens, right?
Yeah.
So what we are going to say is there are 3 resonance structures here that are possible, right?
Yeah.
It could have come from any one of those oxygens, the double bond. So all 3 resonant structures are actually, this is not a great example because all 3 are equivalent. It's not a big difference. There is no
Hmm.
difference between this structure and a structure where the double bond was here, right?
Yeah.
But let's do this example to calculate formal charge, to learn how to calculate formal charge. So we'll say in this structure, what is the formal charge on nitrogen? So formal charge is going to be how many electrons on nitrogen without any bonding? There would have been 5 valence electrons, right?
Yeah. 5.
But right now, what is the electrons that nitrogen can claim for itself?
4. Like, like claim
Number of
as in,
valence electrons in the bonded atom. So it will be
uh,
half of the number of bonding electrons. So these are electrons that are in bonds,
yeah,
right?
so it get, yeah,
So
half
there are how many? There are 4 bonds, so 8 electrons, so half of 8, right?
4. Yeah.
Half of 8 are with nitrogen. There is no lone pair on nitrogen, right? Correct?
Yeah. We didn't assign any law.
There is no electrons left. So there is no lone pair, so that's it. So this is going to be 5 minus 4 is equal to plus 1, right?
Yeah.
If you think of the oxygens, let's think of this oxygen, for example. This oxygen will also be similar. So oxygen, you will say, normally oxygen should have had 6 valence electrons, right?
Hmm. Yeah.
Now notice that there is only one bond, so half into 2, right?
Yeah.
Correct.
Half.
And there are 6 electrons that are completely with this oxygen, right?
Hmm. Yeah.
Those are the lone pair electrons, which are totally owned by the oxygen only, right?
Yeah.
So oxygen has minus 1, this one, right?
Yeah.
Similarly, same thing will happen. This oxygen also minus 1 formal charge, right?
Yeah.
Correct.
All oxygens. Yeah.
This oxygen, let's see, 6 minus half into 4
Half.
minus 4, right?
Yeah. Correct.
So this
Zero.
oxygen is 0, not minus 1. Do you understand what I'm saying?
Hmm. Yeah. Zero.
So how do you calculate formal charge? You take valence electrons of the atom minus half of the bonding electrons minus any non-bonding electrons that the atom owns, like lone pairs and all, right?
Yeah.
So that tells us, okay, what is the rough charge on it as compared to what it would have been when it was on a neutral atom, right? Correct.
Yeah. Yeah. Correct.
So the formal charges are minus 1, and 0 for the oxygens, and plus 1 for the nitrogen, right?
Yeah.
So that's how you calculate formal charge. Now, we have to take a better example where it will be obvious why we are doing all this. So let's look at the book itself. So in the book, if you see, he explains this and then he asks you to find on ammonium ion formal charges, right?
Ammonia. Yeah. Ammonium.
You can see page 275, 7.10 section, right?
Yeah.
So on the ammonium ion, he's doing formal charges. NH4 plus for hydrogen, 1 minus half into 2, and that's it, right?
Yeah. That's it.
So it will be 0 for the hydrogen. And for the nitrogen, it is 5 minus half into 8. That's it, right?
Yeah. So
So it
what?
will be plus 1, right?
Yeah.
So now that's basically a reiteration of what we have learned how to calculate it. Now say what he's saying after that. The value of formal charge calculation comes from their application to the resonance structures described in the previous section. It often happens that the resonance structures of a given substance are not equivalent, right? One of the structures may be better than the others. What that means is it is more closer to the actual electronic structure of the substance, right?
Yeah.
The resonance hybrid in such a case is thus weighted more strongly towards the more favorable structure, right?
Hmm.
So now what are the criteria on the basis of which we can decide which structure is better and all? First of all, there are three. So first criteria is smaller formal charges, either positive or negative, are preferable to larger ones. So it is better to have smaller formal charges to be say to say that it's a more stable structure, right? Because a larger formal charge means there is a large charge separation, no? That usually should not happen, right?
Yeah.
So he's saying 0 is preferred over minus 1, but minus 1 is preferred over minus 2, right?
Hmm.
The less formal charge you have, the better it is, more stable it will be. Because anytime you have actual charges that those charges don't want to be in a charged state, they want to neutralize themselves, right? It's not like they want to be minus 2, minus 3 and all, right?
Yeah. It'll destabilize the thing.
Basically,
Yeah.
it will increase the energy. Charges don't want to be close to each other. It's like charges, right?
Yeah.
So that is the first point. Smaller formal charges are better, right? 0 is better than minus 1. Minus 1 is better than minus 2, right? Then, second point, very important, negative formal charges should reside on more electronegative atoms, right? For example, if
Like,
you see here, nitrogen had plus 1 and oxygen, two of the oxygens had minus 1, right?
Yeah.
Oxygen is more electronegative than almost anything except fluorine. So oxygen and chlorine have highest electronegativity after fluorine, right? And after that comes nitrogen and everything, right? So when you draw formal charges, when you find out the formal charges, it will be better if the negative charge is on oxygen rather than on nitrogen, right?
Yeah.
So if there was an alternative structure here where nitrogen was negative and oxygen was positive, that would be worse. Do you understand what
Huh.
I'm saying?
Yeah.
Because oxygen is more electronegative, it is able to have that negative charge easily, more easily, right?
Yeah.
So that is the second criteria. And the third criteria is like charges should not be on adjacent atoms. So there should not be similar charges on two adjacent atoms. Like charges repel each other. So like charges on adjacent atoms means that there will be repulsion and energy will be increased, right?
Yeah.
If the energy is increased, it leads to instability, lesser stability, right?
Yeah.
So these three rules are going to be useful for us. For example, now the correct example is there, N2O. So let's do it ourselves, N2O nitrous oxide, right? Let's draw the structure of N2O. So we can say that O is here and N, let's say. If we try to draw the structure like this, actually, this might not work. So the actual structure is involving N and O. So let's see how many electrons are there. 5, 5, and 6, right?
So why did you say, like, I know this is, like, this would be the proper way,
We can try
but
the other way also, but maybe it will not give us something. We can try it. It's not like there is a rule to decide, right?
okay.
So we'll try it if you want, but first let's do it for the actual structure that has been shown in the book, right?
Mm-hmm. Okay.
And after that, we can see if there is some problem with this. There is no way to decide which one is there, which one is the correct one. You have to try it out and see. Okay.
And then the formal charges, and
Ah.
then yeah.
So here, if we look at the bonding first, 5, 5, 10, and 6, 16 electrons are there. 2 electrons and 2 electrons here. So 4 are gone. So 12 are left. So I'll put 6 on this and I'll put 6 on this. But notice now there is a problem for the middle nitrogen, right?
It has only four
It has only
electrons.
4. So we can do like this double bond here and like this double bond here, right?
Then I'll have eight.
There is so one obvious structure is this one, right? Correct.
Yeah. Yeah.
Another way you could have done it was not do a double bond with this, but do a triple bond here, right?
Then also nitrogen would get.
Another possible structure is this one, right?
Yeah.
Another possible structure would be a triple bond from this side and single bond here. Do you understand what I'm saying?
Yeah.
All three are possible structures, right? It satisfies the octet of everyone, right?
Yeah.
Now let's do the formal charge calculation for each atom in these structures, right?
Hmm. Okay.
So nitrogen, the middle nitrogen here, 5 minus 2,
Eight,
2, right?
four, one. Yeah. Two.
Plus 1, right?
Hmm.
For this oxygen, 6 minus 4
Two,
minus 2, right?
zero. Yeah.
For this nitrogen, 5
Five
minus 4 minus 2, right?
minus one.
Right. Okay. Let's do this one. For this one, again, it is 5
Five
minus
minus four,
4.
one.
So plus 1 only. For
Yeah.
this nitrogen, it is 5 minus 2
Minus
minus 3, right? So 0.
zero. Yeah. Zero.
And for this oxygen, it is 6
Six,
minus 6 minus 1,
one, minus one. Yeah.
right? And
Hmm.
then this nitrogen here is 5
Mhm.
minus 6 minus 1, right?
Minus two. Hmm.
And this will be still plus 1.
हाँ इसको same
And
तरीके
this will
work.
be 6 minus 2 minus 3. So this is plus 1, right?
Hmm.
So notice first of all that this is a horrible structure because it is, first of all, it is having higher charges than required, right? -2 has come, rather all the other structures had only one charge or zero charge, right?
Yeah.
-2 is there. That is one point that is bad. Second point is that oxygen has positive.
And it's an electronegative, so we'll want
Oxygen is the
negative.
most electronegative out again, and compared to nitrogen, oxygen is more electronegative, right?
Yeah.
And you are assigning a positive charge on it. So this is wrong on two counts, right? Or all three counts actually, if you see +1 and +1 are nearby next to each other.
Like charges shouldn't be together. Yeah.
So basically this structure is discounted and all three things are wrong with it, right?
Hmm. Yeah.
So there is no chance that the actual structure of this molecule will look like this. This has almost zero part in the actual structure. Okay.
Hmm.
Now let's compare this structure and this structure. The charges are -1, 1, and 0 in both of them. So that is not an issue. Then the issue is that oxygen here is 0 and nitrogen is -1. Whereas in this structure, oxygen is -1, nitrogen is 0, right?
Yeah.
So this is a preferred structure because the negative charge is on the more electronegative element, right?
Yeah.
This is preferred over this, right?
Hmm.
And notice that the third point, like charges are not on adjacent atoms, third point is not super valid here, right?
Yeah.
That's not important, but one point that is important is the electronegativity. Which one has a negative formal charge? It should be oxygen rather than nitrogen, right? So
Yeah.
basically what we know is that the actual structure will be a mix of these two, but with a dominance of this one. This one will be more dominant, right?
Yeah.
So the actual structure of N2O will have more than a double bond for sure. It will be closer to a triple bond rather than a double bond, right?
Yeah.
Basically, there is this electron is still delocalized to a certain extent, and this bond here is not exactly a single bond, but it is close to a single bond and not close to a double bond, right? Because this structure is preferred over this structure. Do you
Yeah.
understand what I'm saying?
Yeah, that makes sense.
And also now that will also tell you the, by just looking at this formal charge concept, you can now predict the length of the bonds and all. You can predict that the NN length here will be closer to triple bond length rather than double bond length, right? And similarly, the NO bond length will be closer to single bond length rather than double bond length, right?
Yeah.
Single bonds are the longest, triple bonds are the shortest. All of that stuff we can predict just by formal charges, right?
Yeah.
So that is the benefit of it. And this is just one example. There are many examples like this. And we are able to predict which resonance structure is better, right?
Yeah.
That will tell us the actual structure of the molecule, what is the closest thing, right?
Hmm.
So that is the point, and that's why it is important. You should look at the worked examples carefully, especially the worked example 11, which shows you how to calculate formal charges in organic compounds. The calculation logic is the same, but this kind of thing happens all the time. Like many times in so many chapters, you will see in organic this happening. If you see page 277,
270.
worked example 7.11.
Yeah.
There is a C double bond O, which is like a ketone. On the other side, the ketone, it has become a single bond and there's a double bond C and nitrogen, right?
Yeah.
This is a typical resonance structure where the electron has moved from there to there, right?
Huh.
Now, which structure is preferred? How will we decide that? There is nothing that you can do other than formal charges here. Do you understand the point of it?
Yeah.
How will you decide which structure is actually stable and what will be actual structure of this molecule? The only way to do it is by formal charges. If you calculate the formal charge on the first structure for oxygen, what will it be? 6 minus 4 minus 2, right? 0,
For the first 6 minus 4 minus.
right?
Okay, yeah.
For the nitrogen, it will be 5 minus 2 minus 3 from the three bonds, right? That's also 0.
That's also 0.
But on the other side, on that structure, it is minus 1 on oxygen, 6 minus 1, right?
Hmm.
And it is
Yeah.
plus 1 on the nitrogen.
Yeah.
So that tells us that in one of the structures it is 0, 0, and in one of the structures is minus 1 plus 1, which means more formal charge on the second structure, which is not preferred. It is ideal to have less formal charge, right? One of
Yeah.
the rules was 0 is better than minus 1, right?
Yeah.
So the structure of this compound acetamide will be closer to the first one, right?
Yeah.
So that is the point, and this type of thing happens all the time in organic. You will see many examples of this. So you need to understand it and understand why formal charges are being taught, right?
Okay.
Similarly, like just to expand your knowledge, you should not skip any of this inquiry sections also. Have you read that inquiry section?
No, I always skip it.
हाँ तो ये क्यों ऐसे करते हो? तुमको केमिस्ट्री नहीं सीखना है?
No, I skip the inquiry and go to questions directly.
तो तुमको क्यूरियोसिटी नहीं होता है कि थोड़ा सा क्या बता रहे हैं, क्या दिखा रहे हैं वहां पे इंक्वायरी वाले सेक्शन में?
No, I do, but I think it'll like take more of my time, so I just do the questions directly.
तो मोर ऑफ योर टाइम एंड ऑल इज फाइन. अभी नेक्स्ट डे तो जेई है नहीं, कल परसों तो नहीं है जेई ना, राइट?
हाँ.
The point is to have a little bit of curiosity and read as much as whatever जो भी समझा रहे हैं ये लोग इतना डायग्राम्स के साथ अच्छे से समझा रहे हैं, तो इसको थोड़ा सा पढ़ लोगे तो लॉस नहीं होगा तुमको कुछ, समझ रहे हो ना?
हाँ, लॉस तो नहीं होगा.
कोई लॉस नहीं होने वाला इससे. भूल भी जाओगे तो कोई लॉस नहीं होगा, लेकिन एक चीज कुछ समझ में आ जाएगी. हो सकता है कहीं पे इनडायरेक्टली काम आ जाए किसी क्वेश्चन में लेटर. समझ
अच्छा.
रहे हो मैं क्या बोल रहा हूँ?
हाँ.
ऐसे अपने अंदर के क्यूरियोसिटी को मार के कैसे कोई पढ़ सकता है? मतलब, यू अंडरस्टैंड व्हाट आई एम सेइंग?
या.
यू आर नॉट अ रोबोट कि 1 साल तक बस क्वेश्चंस करने हैं, टाइम बचाना है और बस प्रैक्टिस करना है और यही करना है. यू नॉट अ रोबोट. इफ यू आर रीडिंग अ पर्टिकुलर चैप्टर और कुछ एक एक्स्ट्रा इंफॉर्मेशन दिया जा रहा है पेस्टिसाइड्स के बारे में, कुछ रियल लाइफ के बारे में बता रहे हैं, तो ऑब्वियसली सबको थोड़ा सा इंटरेस्ट होता है. तुमको इंटरेस्ट नहीं होता है उसमें?
नहीं, मुझे होता है बट मैं
हाँ तो
पर्पसली स्किप करता हूँ.
पर्पसली स्किप करते हो, पर्पसली अपने आप को टॉर्चर कर रहे हो. मतलब थोड़ा सा इंटरेस्ट है, क्यूरियोसिटी है, थोड़ा सीख जाओगे नया तो कुछ लॉस नहीं होगा उसमें. समझ रहे हो क्या बोल रहा हूँ मैं?
हाँ.
उससे गेन ही है बस. यू नीड टू रीड ऑल ऑफ द इंक्वायरी सेक्शंस इन एवरी चैप्टर नाउ.
ओके.
The reason I am saying is sometimes you don't know when knowledge will be useful, or all of these inquiry sections might give you some extra information. थोड़ा सा एडवांस्ड होगा लेकिन समझ में आएगा कि क्या हो रहा है. कुछ एक्स्ट्रा समझ में आ जाएगा, स्ट्रक्चर्स दिखेंगे. मतलब इसको स्किप करने का कोई पॉइंट ही नहीं है, स्किप करने का. समझ रहे हो क्या बोल रहा हूँ?
हाँ.
फाइनली जेई एडवांस्ड में कुछ सरप्राइजिंग ही चीज आता है. यूजुअली कुछ नया आएगा, कुछ नया दिखेगा जो पहले नहीं देखे होगे. अगर तुम इंक्वायरी और ये सब पढ़ते रहोगे तो तुमको आइडिया रहेगा कि कुछ नया आता है तो उसको कैसे समझना है. यू नीड टू बी एबल टू सी समथिंग न्यू एंड नॉट गेट स्केर्ड ऑफ इट. यू
हाँ.
अंडरस्टैंड व्हाट आई एम सेइंग?
या.
जेई एडवांस में भी बहुत सारे आते हैं कॉम्प्रिहेंशंस, कुछ हर साल कुछ कुछ नया लाते हैं. वो कहाँ से लाते हैं? वो यही सब बुक्स में से लाते हैं ढूंढ के.
अच्छा.
और
हाँ, ठीक
एग्जाम
है.
पर्सपेक्टिव से मैं बोल ही नहीं रहा हूं. मैं बोल रहा हूं कि यहाँ पे इस जगह ऑर्गेनोफॉस्फेट्स का पेस्टिसाइड्स में एप्लीकेशन होता है, उसको अच्छे से समझाया हुआ है और रेजोनेंस और फॉर्मल चार्जेस के बेसिस पे समझा रहे हैं. तो ये सीखना है ना, ये पता करना है. ये सब सब इम्पोर्टेंट हो सकता है कहीं ना कहीं लाइफ में लेटर, आई डोंट नो. but it is definitely not going to harm your chemistry understanding. You
हाँ
understand what I'm saying?
हाँ
तो टेक एडवांटेज ऑफ व्हाट रिसोर्सेज यू हैव, जबरदस्ती स्किप कर रहे हो, सब चीज पढ़ना है जो भी दिया हुआ है इसमें।
ठीक है।
समझ रहे हो?
हाँ
इसमें क्वेश्चन क्वेश्चन में भी देखोगे कहीं कहीं एग्जाम्पल्स हैं और क्वेश्चंस हैं जिसमें इबुप्रोफेन इज लाइक अ मेडिसिन, उसका
हाँ
उसका स्ट्रक्चर दिया हुआ है और रेजोनेंस स्ट्रक्चर्स के बारे में बात कर रहे हैं शायद। बहुत सारे क्वेश्चंस में इंपॉर्टेंट केमिकल्स के बारे में है। ऑल ऑफ इट यू शुड रीड, एंड यू शुड रीड इट विथ अ सेंस ऑफ प्लेजर, नॉट एज अ सेंस ऑफ होमवर्क करना है। नया सब्जेक्ट सीखने का एक जॉय होता है, कुछ नया देखने का। वो जॉय तो तुमने पूरा खत्म ही कर दिया है। नई नई चीज सीखने में कुछ मजा नहीं आता है, कुछ नया पता चला देखो ये क्या है, कुछ ऐसा फीलिंग नहीं आता तुमको?
नहीं आता है।
तो वो वाला फीलिंग को नर्चर करके उसको जिंदा रखना है। समझ रहे हो?
हाँ।
ये जेई प्रेपरेशन इज नॉट द एंड ऑफ योर लाइफ ना, उसको मार नहीं देना है।
हम्म।
ओके।
या मैं, हाँ मतलब।
चैप्टर 8, चैप्टर 8 में फर्स्ट थिंग इज वीएसईपीआर मॉडल। समझ में आया मॉडल?
एक सेकंड, वो मुझे क्वेश्चन मिल गया, इसमें मुझे डाउट था।
कौन सा
सेवेंथ
क्वेश्चन?
चैप्टर में, वो 7.42।
ओके, एक्सरसाइज में है।
हाँ
7.42, ऑर्डर द फॉलोइंग elements according to increasing electronegativity. Okay. I, iodine, nickel, cesium, strontium, aluminum, potassium. This question.
हाँ।
Increasing
लाइक,
electronegativity. So तुमको सबके ग्रुप्स पता होने चाहिए। पता है हमको कि के फर्स्ट ग्रुप में है, राइट?
हाँ के फर्स्ट में।
सीजियम, स्ट्रॉन्टियम, ये सब सेकंड ग्रुप है शायद, CSNSR।
सीजियम पोटाशियम के
सीजियम
नीचे।
पोटेशियम के नीचे है।
हाँ।
LiNa, सीजियम, फ्रांशियम, ऐसा होता है शायद। क्या है अगला? ऐसा है। और स्ट्रॉन्टियम यहाँ पे
सीजियम,
कहीं पे है।
सीजियम और फिर फ्रांशियम।
मैग्नीशियम, बेरिलियम, मैग्नीशियम, यहाँ पे स्ट्रॉन्टियम है, राइट, कहीं पे नीचे में। करेक्ट।
अभी, हाँ
तुम पीरियोडिक टेबल में देखो खोल के। ये ऑब्वियसली ये क्वेश्चन के लिए तुमको पीरियोडिक टेबल देख के करना है। तो पीरियोडिक
अ,
टेबल देखो और उसमें पोजीशन सबका देखो कहाँ कहाँ है।
अच्छा।
एल्युमिनियम थर्ड ग्रुप में है। फिर उसके बाद निकेल ट्रांजिशन एलिमेंट्स में है कहीं पे, राइट?
हाँ निकल ट्रांजिशन।
और आयोडीन उधर है, उस साइड में है। आयोडीन यहाँ पे है, सेवेंथ ग्रुप में, राइट? सो इट इज एन
हाँ
ऑब्वियस ऑर्डर। इलेक्ट्रोनेगेटिविटी इंक्रीजेस लाइक दिस, दैट्स द ऑर्डर, राइट?
या मीन, मुझे वो याद नहीं है, बनाना है
याद
बट।
नहीं करना है, बट रफली पता होना चाहिए ना। हम मुझे रफली तो पता ही था कि पोटेशियम, ये सब मेटल्स हैं और इस साइड में है। और एल्यूमिनियम थर्ड में है, निकल ट्रांजिशन, ये सब तो पता ही था। इसमें मैंने देखा नहीं है अभी पीरियोडिक। मुझे बस कंफ्यूजन सीजीएम और इसमें था कि वो
हम्म।
सेकंड में है कि फर्स्ट में है। लेकिन पीरियोडिक टेबल इतनी बार देखना है कि रफली आइडिया होना चाहिए। You need to know the names of the elements in your groups roughly. It doesn't have to be all of them or something.
हाँ हाँ
समझ में आ रहा है मैं क्या बोल रहा हूँ?
हाँ, नहीं वो तो पता है, बट मैं बोल रहा था कि डाउट मुझे याद नहीं मेरा क्या था।
डाउट होगा कि के और सी एस में कौन सा होगा, तो इलेक्ट्रोनेगेटिविटी शुड बी लेसर फॉर सी एस, राइट?
हाँ, डिक्रीजेस डाउन द ग्रुप।
सो इलेक्ट्रोनेगेटिविटी इज लेसर, सो सबसे लेस इलेक्ट्रोनेगेटिव सी एस का होगा, उसके बाद के आएगा, राइट?
उसके
उसके
बाद
बाद ये सब आएगा, राइट?
हम्म।
डू यू अंडरस्टैंड व्हाट आई एम सेइंग?
हाँ
अगर एक ही होता है इस ग्रुप में तो ऑर्डर तो ऐसा होता है ना, बढ़ने का ऑर्डर।
हाँ
अगर मान लो एक ही होता सब पीरियड्स के एलिमेंट्स, तो ऑर्डर ऑफ इंक्रीज शुड बी लाइक दिस, राइट?
Yeah.
बट यहाँ पे दो दे दिए हैं, तो इनके बीच का ऑर्डर डिसाइड करना है बस, राइट?
Yeah.
इनके बीच का ऑर्डर कैसे डिसाइड करेंगे? विल से दैट इलेक्ट्रोनेगेटिव विल डिक्रीज डाउन द ग्रुप, राइट? तो सबसे लेस तो यहाँ होगा।
But between aluminium and nickel,
हम्म।
अच्छा, okay, okay.
We are
Nickel would be
following
less,
a general trend. Nickel is a transition element. It's not in the main groups, right?
so would nickel be lesser than aluminium or more?
तुम इंडिविजुअल एटम्स का थोड़ी कैलकुलेट कर सकते हो भाई। ऐसा थोड़ी नॉलेज है कि तुमको इलेक्ट्रोनेगेटिविटी का नॉलेज है कि एक दो एटम्स को कंपेयर कर सकते हैं। ऐसा कैसे नॉलेज होगा किसी को?
तो फिर वो ऑर्डर कैसे लिखूंगा?
ऑर्डर लिख रहे हैं इस जनरल ट्रेंड से। एल्यूमिनियम कहाँ है पीरियोडिक टेबल में?
It's in the 13th, like, or
इट इज
nickel.
ग्रुप 3।
हाँ, like, yeah, group 3.
और निकेल उसके राइट साइड में है कि लेफ्ट साइड में?
Left.
निकेल लेफ्ट साइड में है इसके।
हाँ.
क्या बोल रहे हो भाई?
Nickel is on the left of aluminium, no?
हाउ?
Nickel is the transition and aluminium is there.
तुमको पीरियोडिक टेबल का स्ट्रक्चर नहीं पता है?
मैं पीरियोडिक टेबल देख के बता रहा हूँ.
पीरियोडिक टेबल कौन सा तुम देख रहे हो अभी?
नॉर्मल.
कहाँ पे देख रहे हो?
मैंने एक प्रिंट आउट लिया था वो मैंने.
ठीक है, रुको मैं देखता हूँ बुक में क्या लिखा हुआ है पीरियोडिक टेबल में। रुको अब एक सेकंड। ओके। हाँ तो पीरियोडिक, हाँ मैंने ही थोड़ा सा गलत बोल रहा हूँ। निकेल पीरियोडिक टेबल में ट्रांजिशन एलिमेंट्स आर बिफोर द 13th ग्रुप,
या.
राइट? सो
हम्म.
बिफोर द 13th ग्रुप है तो फिर बोलेंगे निकेल पहले होगा एल्यूमिनियम के। वी आर सेइंग इट ऑन द बेसिस ऑफ अ ट्रेंड, नॉट ऑन द बेसिस ऑफ, वी कांट डिसाइड इट ऑन द बेसिस ऑफ इंडिविजुअल एटम। समझ में आ रहा है मैं क्या बोल रहा हूँ?
हाँ, but like since it's before aluminium, so it should be lesser. अच्छा,
यस,
okay, lesser.
वही तो बोल रहा हूँ।
हाँ,
मैंने उल्टा ऑर्डर बोला था इसलिए मेरा गलत हो रहा था।
हाँ, हाँ, okay, got it.
It's based on the trend that this side as you go it increases, right? And I was
Yeah.
saying that this transition element position was wrong. It should be like this, and then the third one comes here.
Yeah.
1 second, just hold on for a moment. One second.
Okay.
हाँ। सो ओके, तो ये क्लियर है ना, ये क्या इसमें हो रहा है?
हाँ,
VSEPR मॉडल समझ में आया है?
हाँ.
ओके। 1 सेकेंड, उसमें स्ट्रक्चर्स तुम प्रेडिक्ट कर सकते हो, कोई भी कंपाउंड में दूंगा उसका स्ट्रक्चर अच्छे से।
Yeah, I should be able to do it.
तो बेसिकली द मॉडल इज अबाउट, यू हैव टू अंडरस्टैंड दैट जो बॉन्ड होता है सिंगल बॉन्ड उसको बोलते हैं एक चार्ज क्लाउड, राइट?
Yeah.
और द लोन पेयर ऑफ इलेक्ट्रॉन्स होता है उसको भी बोलते हैं, वो भी एक चार्ज क्लाउड है एटम के अराउंड, राइट?
हाँ.
अल्टीमेटली क्या होता है मॉडल में कि we count how many charged clouds are around each atom. First, we draw the electrons dot structures, right? ऐसा करके
Yeah.
कुछ भी इलेक्ट्रॉन डॉट स्ट्रक्चर पहले ड्रॉ करते हैं. उसके बाद हर एटम के अबाउट और स्पेशली सेंट्रल एटम के अराउंड यू हैव टू काउंट हाउ मेनी चार्ज क्लाउड्स आर देयर, राइट?
Yeah.
तो हो सकता है 4 हो, 3 हो, 6 हो. इट कुड बी एनीथिंग, राइट? नंबर ऑफ चार्ज क्लाउड्स विल बी नंबर ऑफ बॉन्ड वाले इलेक्ट्रॉन्स, लोन पेयर इलेक्ट्रॉन्स, ऑल ऑफ देम काउंट एज चार्ज क्लाउड्स, राइट?
Yeah.
Once you have done that calculation, after that, the basic idea of the model is that the charge clouds want to be as far apart from each other as possible, right?
Yeah.
That's the valence shell electron pair repulsion model. Electron pairs will repel each other and want to be as far apart from each other as possible, right?
Yeah.
और अब धीरे धीरे अगर तुम पढ़ोगे तो हर केस में 2 चार्ज क्लाउड्स, 3 चार्ज क्लाउड्स एग्जाम्पल्स के साथ और फिगर्स के साथ बताया हुआ है बुक में कि कैसा स्ट्रक्चर होना चाहिए, राइट? टू
हाँ.
टू चार्ज क्लाउड्स में दे हैव टू बी फार अपार्ट, सो 180 डिग्री एंगल होना चाहिए दोनों के बीच में, तो लीनियर स्ट्रक्चर बन जाएगा मॉलिक्यूल का, राइट?
Yeah.
3 चार्ज क्लाउड्स में दे वांट टू बी एज फार अपार्ट एज ईच अदर, तो 120 120 120 सबसे फार होगा, राइट? ऐसा. तो इसको बोलते हैं कि एक ट्रायंगल टाइप का बन गया, ट्राइगोनल प्लेनर, राइट?
हाँ.
In a plane, this is the farthest that charge clouds can be, making 120 angles between each other, right?
हाँ.
So
Yeah.
this structure becomes a trigonal planar structure. उसके बाद फिर 4 चार्ज क्लाउड्स में टेट्राहेड्रल स्ट्रक्चर, बहुत अच्छे फिगर्स के साथ है, तुमको विजुअलाइज करना बहुत इंपॉर्टेंट है इस सेक्शन में, राइट?
Okay.
यू हैव सीन द बुक्स एंड द फिगर्स, नो? सब ठीक से.
हाँ, देखा है.
उसके बाद अगर चार्ज क्लाउड में एक लोन पेयर आ जाएगा तो लोन पेयर इज डिफरेंट फ्रॉम बॉन्डिंग पेयर, और उसके कारण बॉन्डिंग इलेक्ट्रॉन्स और लोन पेयर में डिफरेंस है कि इट विल पुश द अदर वंस लिटिल फर्दर अवे, राइट?
Yeah.
प्रेजेंस ऑफ लोन पेयर्स के कारण थोड़ा सा और डिस्टॉर्ट हो जाता है. तो फॉर एग्जांपल वाटर मॉलिक्यूल में द 120 120 120 is not preserved. The two OH will have a smaller angle, like 104, right?
Yeah, because of the two lone pairs on this.
हाँ, the lone pairs के बीच का repulsion is higher than the lone pair versus the charged clouds, right?
Yeah.
So that is a thing that you need to know. Similarly, अमोनिया के स्ट्रक्चर में भी बताया गया है कि अमोनिया में टेट्राहेड्रल का एंगल होता है यूजुअली 109.5, राइट?
Yeah.
जो मीथेन मॉलिक्यूल में है CH4 में. बट अमोनिया में एक लोन पेयर है जिसके कारण वो एंगल थोड़ा सा रिड्यूस हो गया है, द NH एंगल्स,
Yeah.
एंड बिकम्स 107 डिग्री बिकॉज द लोन पेयर रिपेल्स अ लिटिल मोर, ओके?
Hmm.
और अगर 2 लोन पेयर्स है तो वाटर टाइप का स्ट्रक्चर बन जाएगा जहां पे 104.5 डिग्री एंगल है, राइट?
Yeah.
देन 5 चार्ज क्लाउड्स which gives us a structure where there is a triangle in the middle and there is a pyramid up and down, bipyramidal, right?
Yeah.
One thing will be on top of the triangle, one thing will be below the triangle. This is one and this is one. This is the trigonal bipyramidal structure, right? This is for
Yeah.
5 charge clouds. उसमें अगर लोन पेयर आने लगे तो तुम लोन पेयर यहां पे डाल सकते हो, एक लोन पेयर, तो ये हो जाएगा सीसॉ शेप, राइट?
Yeah.
एक और लोन पेयर अगर आ गया तो ये हो जाएगा टी शेप. ये भी लोन पेयर अगर हो गया, राइट?
हाँ, T-shape.
बेसिकली 5 चार्ज क्लाउड्स वाला ट्राइगोनल बाइपिरामिडल में स्ट्रक्चर में एक लोन पेयर, 2 लोन पेयर और 3 लोन पेयर में वो सीसॉ शेप, टी शेप और लीनियर शेप बन जाता है, राइट?
हाँ.
सिमिलरली ऑक्टाहेड्रल स्ट्रक्चर होगा जब 6 चार्ज क्लाउड्स होंगे, लेकिन वहां पे हम लोग ऊपर में उसको we will say there is a square type or a square type of a structure here and one here atom, right? And this is our central atom, correct?
Yeah.
तो
Correct.
यहाँ पे अगर चार्ज क्लाउड्स होंगे तो ऊपर में इसको चार्ज क्लाउड्स बना देंगे, तो यहाँ पे एक स्ट्रक्चर होगा, पिरामिडल टाइप ऑफ एक स्ट्रक्चर बनेगा, राइट? और एक
हाँ एक।
स्ट्रक्चर बन जाएगा प्लेनर, राइट?
हाँ।
If there is one lone pair, it will be a pyramidal octahedral type of structure. उसका नाम मैं भूल रहा हूँ अभी, देखना पड़ेगा क्या नाम है उस स्ट्रक्चर का, सिक्स में जब एक चार्ज, एक लोन पेयर होता है तो।
स्क्वायर पिरामिड।
हाँ, स्क्वायर पिरामिड। एंड उसके बाद अगर दो लोन पेयर होगा तो यू विल कॉल इट स्क्वायर प्लेनर। अप एंड डाउन आर लोन पेयर्स नाउ, सो दे आर गॉन, राइट?
या।
When it's not a lone pair, it's an actual atom there, so you cannot delete it, right? When it's a lone pair, it will not be visible too much because there's no atom on top, right?
या।
So this VSEPR model is super important. Knowing the structure of atoms and molecules helps us predict how they will react. तो स्ट्रक्चर जानना सबसे पहला चीज होता है, स्पेशली इन ऑर्गेनिक केमिस्ट्री। बहुत जगह तुम देखोगे ऑर्गेनिक मॉलिक्यूल्स विल बी बिग एंड कॉम्प्लिकेटेड। इफ यू नो देयर स्ट्रक्चर यू कैन प्रेडिक्ट हाउ इट विल रिएक्ट। ओके, सो द VSEPR मॉडल इज लाइक द फर्स्ट स्टेप। इट्स लाइक अ स्मॉल स्टेप। छोटे मॉलिक्यूल्स के लिए हम लोग स्ट्रक्चर प्रेडिक्ट कर सकते हैं, इसी को एक्सटेंड करके ऑर्गेनिक में भी स्ट्रक्चर प्रेडिक्ट करना पड़ेगा, राइट?
ओके।
Then after that, there is hybridization. There is many other concepts here. So what we will do tomorrow is just go through the chapter. If there is any doubt, we'll fix all the doubts tomorrow. Like whatever else is there conceptually, और
हम्म।
कुछ अगर issue होगा तो बताना. We'll discuss it tomorrow and try to finish it. And molecular orbital theory also we have to discuss tomorrow.
ओके एंड।
Molecular orbital theory is the extension of our quantum mechanics that we did for the atom. Okay.
हाँ या।
बेसिकली एटम में हम लोग एक एटम पे बोलते थे ना कि इलेक्ट्रॉन्स आर wave functions which are the solutions of the Schrodinger equation, right? And the wave function has some quantum numbers associated with it which correspond to the electronic orbitals, right?
या।
यहाँ पे बोलेंगे कि अब मॉलिक्यूल है and we are going to write the Schrodinger equation for a full molecule, and from there the solutions that come are molecular orbitals, right?
या।
So it is a little complicated, but you don't have to worry about the maths of it. All you need to know are the general qualitative idea of it. Qualitatively सीखना है अभी तुमको, quantitative नहीं होना है इसमें, right? तो
हाँ
बस descriptive way में पता चलना चाहिए कि क्या हो क्या रहा है. It doesn't have to be like mathematically precise right now. So
या।
what you need to make sure is you understand everything that is in the sections that are taught here. 8.7, 8.8, 8.9. ये तीन सेक्शंस अगर अच्छे से पता है तो फिर ठीक होगा.
अच्छा ठीक है।
मतलब मेक श्योर दैट नथिंग इन द बुक हियर यू डोंट नो. एवरीथिंग हियर इफ यू नो, you are already at a reasonable level and you can answer basic questions on it then.
ओके मैंने इसके सारे वो क्वेश्चंस लगा लिए थे, तो मुझे कुछ और इस
हम्म.
इन चैप्टर्स के पीवाईक्यूज भी लगाने हैं।
अभी नहीं करना है क्योंकि हम लोग ये अभी पीवाई यूज नहीं करना है, क्योंकि हम लोग को इससे भी थोड़ा सा स्लाइटली हायर लेवल पे जाना है. राइट नाउ वी आर नॉट गोइंग टू डू इट बट वी आर गोइंग टू डू इट लेटर. सो पीवाईक्यूज करने से पहले हम लोग को थोड़ा सा देखो, ये केमिकल बॉन्डिंग और ये सब सब चैप्टर्स क्वाइट इंपॉर्टेंट है, और इसमें तुमको फाइनली वी विल डू अनदर बुक आल्सो, विल रीड अ लिटिल बिट जेडी ली.
तो हाँ ये दीदी के पास थी, रखी है।
हाँ, this book is slightly advanced and this is the book that we will be reading a little bit, but now is not the time for it. Now is the time. We are already, if you do the book and the chapter questions and all, you are already at JEE mains level, most of the questions. Especially in this, 90% of JEE mains level questions you can answer if you know everything in the chapter. So for going to the extra level, slightly higher level, we will be doing other things before. But right now, our priority will not be like doing PYQs right now. Our priority will be to know as much of chemistry as possible, which means finishing this book. समझ
ओके।
में आ रहा है मैं क्या बोल रहा हूँ?
हाँ
हम लोग का प्रायोरिटी अभी ये नहीं कि हम लोग को इसको बहुत हाई लेवल पे ले जाना है इमीडिएटली. दैट्स नॉट हाउ यू लर्न अ सब्जेक्ट. एक ही चैप्टर को करते रहोगे ना तो बोर्ड हो जाते हो ना, बोर्डम होगा फिर. समझ रहे हो क्या बोल रहा हूँ मैं?
हाँ।
एक ही चैप्टर को करने में किसी को मन नहीं लगता है. तो अभी हम लोग ने जितना सीखा है, तुमने अगर एक्सरसाइज सही से बनाया है तो तुमको ऑलरेडी आता है बेसिक्स, राइट?
हम्म।
After this, we have to move on and learn more chemistry. We need to finish the whole book, learn all the chemistry. After that, we will start improving specific chapters में थोड़ा सा और higher level. लेकिन the process of studying chemistry has to be interesting. That's the first criteria. Do you understand what I'm saying?
या।
अगर वो बोरिंग हो जाएगा और ऐसा हो जाएगा कि अरे कौन पढ़ेगा, तो फिर कोई चांस नहीं उसमें इंप्रूव करने का. So we want to quickly go to chapter 9, chapter 10. We have to progress fast and we have to finish the book. The target for finishing the book is 2 months or 2.5 months or 3 months. Do you understand what I'm saying?
हाँ। ओके।
Finishing the book will mean physical or inorganic, not inorganic completely, but physical तो quite decent level पे हो जाएगा already. Inorganic complete नहीं होगा, लेकिन इसीलिए 3 months का टारगेट है. उसके बाद फिर और करेंगे, but that will be with other sources. Do you understand what I'm saying?
हाँ। ओके।
The only thing that will be common is organic में जैसा बताया गया है वैसे ही करना, और कुछ मत करना. Organic में there is nothing else can be done. You have to go through that textbook that you are doing, and जो भी क्लास में हो रहा है उसको ढूंढ के पढ़ना है वहां से. ठीक है?
हाँ। ठीक है।
Physical or inorganic में we'll do multiple things, but our first target here is to finish this book fast. So we're not going to spend too much time doing PYQs right now. We'll get time to do PYQs later.
ओके।
और make sure that you read the inquiry section of every chapter
ओके।
just for extra knowledge and some slightly advanced topics. Just for curiosity. It's not going to come in the exam,
हाँ।
right?
या।
You have to approach the subject like you approach like something that you do out of your interest, not like you because you have to prepare for an exam. You have to do it as if you are actually interested in the subject. थोड़े दिन फेक करोगे तो एक्चुअल इंटरेस्ट भी हो सकता है आ जाए. समझ में आ रहा है
हाँ।
मैं क्या बोल रहा हूँ?
हाँ।
अगर असली में इंटरेस्ट नहीं है, लेकिन तब थोड़े दिन तक फेक करना पड़ेगा इंटरेस्ट, उसके बाद एक्चुअल इंटरेस्ट खुद खुद आने लगेगा.
ओके।
बट स्टडी द बुक एज इफ लाइक द बुक इज द सोर्स ऑफ इंफॉर्मेशन दैट is not just for an exam, but it's teaching you the subject. So you have to respect that and study it properly. And we need to proceed further in it. Try to do as much as possible, as fast as possible. We are not going to wait and same chapter को करते रहेंगे 2 weeks तक. वो सब नहीं होगा. ठीक है?
ठीक है।
मेक श्योर 8.7, 8.8, 8.9 फिर से पढ़ लो ताकि वो समझ में और आ जाए. वो क्लियर होना चाहिए.
हाँ। ठीक है।
ओके, फाइन. विल कंटिन्यू टुमारो देन.
ओके। थैंक यू सर। बाय।
बाय.